Megger testing is a procedure used to evaluate the insulation resistance of electrical conductors and equipment. This is crucial for ensuring electrical safety and preventing potential faults. Here's a breakdown of how to perform Megger testing properly. Before commencing any testing, ensure all circuits are de-energized and the equipment is completely isolated. This prevents electrical shock and damage to the testing equipment. Wear appropriate personal protective equipment, including insulated gloves and safety glasses, to further minimize risk. Configure your Amprobe model AMB45 Megger by setting it to the desired test voltage. 500 volts is typically used for insulation testing on standard electrical systems, but always refer to the equipment specifications or relevant standards for the appropriate voltage level. Connect the ground lead of the Megger to a known good earth ground or a conductive surface that is reliably grounded. This provides a reference point for the test and ensures accurate readings. Now let's look at the specific test procedures. For a line-to-line test, connect the line 1 and line 2 leads of the Megger to two conductors of the same phase. This test measures the insulation resistance between these two conductors. Observe the insulation resistance value displayed on the meter. This value indicates the condition of the insulation between the conductors. For a line-to-neutral test, connect the line lead to a conductor of a phase and the neutral lead to the neutral conductor of the circuit. This test assesses the insulation between the phase conductor and the neutral conductor. Read the insulation resistance value shown on the meter. This reading will tell you the condition of the insulation. For a line-to-ground test, connect the line lead to a conductor of a phase. Then, connect the neutral and ground leads together. This test measures the insulation resistance between the phase conductor and the ground. Observe the insulation resistance value displayed on the meter to assess the insulation condition. Proper interpretation of the test results is critical. A high insulation resistance, for example, greater than 1 megohm, generally indicates a good insulation condition. This suggests that there are no significant current leakage paths between the conductors being tested. A low insulation resistance, such as less than 1 megohm, suggests a poor insulation condition. This could indicate potential current leakage or damage to the insulation, requiring further investigation. An infinite insulation resistance or an open reading indicates no measurable current flowing through the conductors tested. This may suggest a complete break in the insulation or an open circuit. Here are some additional tips to keep in mind. Ensure that the test leads are clean and making good contact with the test points. Poor connections can lead to inaccurate readings. If possible, discharge the circuit before testing to avoid potential damage to the Megger. Capacitive circuits can store energy, which can affect the test results. Record the test results for future reference and troubleshooting purposes. This historical data can be valuable for identifying trends and potential problems. Always follow the manufacturer's instructions and relevant industry standards for safe and accurate Megger testing. These guidelines provide important information about the proper use of the equipment and safe testing practices. Remember to always prioritize safety when working with electrical equipment. To energize circuits, wear appropriate personal protective equipment, and follow established safety procedures to minimize the risk of electrical shock or injury. By following these steps, you can effectively use a Megger to test the insulation of wires and electrical equipment, ensuring safety and preventing potential failures. Always remember that interpreting Megger readings requires experience and knowledge of the specific system being tested. Consult with qualified professionals if you are unsure about the results.